This time around, we're going to be talking about inheritance, and this is how we take one class and we derive a new one from it. This creates what we call the is-a relationship, in the sense that a lab is a course, a truck is an automobile, a carrier is a ship. So we're taking a more generalized class and we're creating something that is more specific. Oftentimes, parent classes or superclasses are abstracted so far to the point that they are not used themselves. They're too vague. However, they are used to create more concrete subclasses or child classes. Now, when we perform inheritance, just like with genetics, aspects of the parent class are taken to the child class. In the case of programming, it's pretty much all of the members and methods that are taken from one to the other, at least in Python. Some programming languages specify private and public components to our classes, and private ones are not inherited, but public and protected ones are. But in Python, everything is inherited. And of course, we would need to be able to reference the superclass or the parent class from our child subclass. And the way we do this is just by using the super method. So here's an example of some inheritance. This is a very basic form of inheritance. We have a student class. This student has a name. From this, we derive our undergrad student, or just undergraduate, and we pass into some parentheses the superclass that it derives from. Then we have our dunder init, which takes self, name, and year. We call dunder init from our superclass in order to instantiate the instance member variables of the student class that we derive from, and then we do the year. We define it exactly as you would normally. And then we have our dunder repr. We have name, self.name, and then on the next year, next line, we have year and self.year, and then we return rep. Or you could turn this to string. So we're going to click on over to our code here. We're going to take this character class, and we're going to make a player character out of it. And we're going to add exactly one item to it. We're going to add an inventory. It's going to be a list of strings representing the items that the player has. So we're going to come down here, and we're going to say class player character, and we're going to hand it character as its superclass. Colon. Next line, we're going to say def dunder init self name species HP and inventory. All right, this looks like a lot, but it's going to be a very simple function. We say super dot dunder init, and we hand it name species HP. Let's look back here and double check that is correct. All right, so now we do self dot inventory equals inventory. We could do a little bit of error checking here. You'll see when we do composition what I mean by that. But that's going to do it for our dunder init. Very, very simple, because we've already defined all of this up here. We don't need to do these again. We can just call the superclass init function. So now we're going to do our dunder string, def dunder str. As always, hand it self, So we're going to do our toString equals. First off, we're just going to say string or super dot, dot dunder str. Whoops. I cannot type all of a sudden. This should work. And now we're going to toString plus equals a new line, another tab, inventory. And we're just going to print this raw. We're not going to do anything crazy. We just want to see this in action. So plus self.inventory. Okay, this ought to work. Let's have a look at what it looks like in our composition code here, because this will show us. No, it will not. Okay, we might have to do a little bit of trial and error here. So we'll see if this works. This looks a bit strange. It could just be str super. Let's try that because that looks simpler. Let's see if this works. Return to string. All right, now let's do another test class. So we'll say new player equals player character, and we'll hand it Fiera. We'll say that she's a tiefling. I don't know if I'm spelling that correctly. She has 120 hit points, and her inventory is not but a single potion. And now we will print str new player. Let's see if this works. Make sure it's saved. Let's try it. Whoops. And does it work? Of course it doesn't. So let's look at our stack trace here. toString plus equals inventory. The only problem appears to be self.inventory, which we need to cast to a string because it is a list. str that. Save. Let's try again. All right, and it returns not what we want. So let's try the other method that we were using before. Super dot dunder str. There we go. That's what we needed to do. So this was correct the first time I did it. So this is how it works. It's a bit messy. It takes a little bit of getting used to, but we are just returning a stringification of the superclass definition that exists within our subclass. And that's really all there is to inheritance. Some questions you might have are, what about multiple inheritance? That's not really much of a thing in most programming languages. You might find it in languages like Go, but generally you only want to inherit from a single class. So a lot of languages only allow you to do that much. So this is inheritance in a nutshell. We're going to take tons of time in class and actually talk about it and do a lot of examples, pardon me. But when we come back to our next lecture, we're going to take a look at composition. That is, the has a relationship. So we're going to create a new class and we're going to hand it into our existing character class. So, stick around.